So let's see what we can figure out about triangles. That's what this module is. Now, one of the first things, the most fundamental thing in studying triangles is to realize that when you have a triangle, the sum of the angles that make up that triangle on a plane is going to be 180 degrees for whatever triangle. As long as it's on a flat surface, the sum of those angles is going to be 180 degrees. And those are the triangles that we're going to study, those that are on the plane. Now, I want to I've done this before, but I want to carefully show you how we know that to be true. If you look at this triangle that I have, right here, you'll notice that I have the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. The sum of those is 180. The sum of those measures is 180 because they form a straight angle. Now, we also know that we have this line here, which I drew. This is just an arbitrary parallel line that I drew up here to be parallel to this. We know that these two lines are parallel and they're cut by this transversal. That means the alternate interior angles, angle 1 is congruent to angle 4. Okay? So angle 1 is equal to angle 4. So I could rewrite this thing up here as the measure of angle 4 plus the measure of angle 2 plus the measure of angle 3 is equal to 180. Just substitute. Since 1 has the same measure as 4, instead of measure of angle 1, I'll just put the measure of angle 4. Okay? Now, by the same reasoning, we know that the measure of angle 3 is equal to the measure of angle 5. So now let me rewrite this. So now we've got the measure of angle 4 plus the measure of angle 2. And instead of the measure of angle 3, I'll write the measure of angle 5. Just a little bit of substitution. Now, look what we have here. 2 plus 3, see, measure of angle 4 plus the measure of angle 2 plus the measure of angle 5. Ooh, those are the three angles in the triangle, and they equal 180. So we've got that. Now, so let's move on from that and see if we can make any more observations here. If we take a triangle and extend the side, like this triangle here, if I extend one of those sides like this, I get another angle formed here. In this case, I have a triangle with angle 2, 3, and 4, and then I extend this side out and I get angle 1. Now, I could have extended other sides and got angles, but we call this an exterior angle. Whenever we do that, whenever we extend a side and we get an angle out here, we call that an exterior angle. Now, here's the thing about exterior angles. If you take the measure of an exterior angle, it's going to be equal to the sum of the measures of the two remote interior angles. Now, I call the remote interior angles, see, this angle here is adjacent to this one, okay? These are remote, so they're the angles that are not adjacent. So measure of angle 1 is equal to the sum of the measures of the remote interior angles. Now, how do I know that's true? Well, here's how I know it's true. Notice that the measure of angle 1 plus the measure of angle 2 is equal to 180. Okay? And we know that because these form a straight angle. Okay? The angle 1 and angle 2 form a straight angle. So we know that's true. And here's something else we know. We also know that the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4, that also equals 180. Okay? So we know that because those are measures of the in the angles of a triangle. Okay, now dig this. We've got the measure of angle 1 plus the measure of angle 2 is 180. The measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 180. Therefore, this being the case, since they both add up to 180, then the measure of angle 1 must equal the measure of angle 3 plus the measure of angle 4. It has to be, right? Because measure of angle 1 plus the measure of angle 2 is 180. Therefore, the measure of angle 2 must and since the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 is 180, I can just replace these two with the measure of angle 2. You see there, I can make a substitution in there. Okay. So we know when we add these three things up, we get 180. And when we add these two things up, we get 180. So I can just replace, I'll keep 2 the way it is and say, well, angle 1 must be the same measure as angle 3 plus angle 4. Yeah. So anyway, that's how we know that's true. So if you look at this example here, we've got this exterior angle. I will leave off the degree symbol. I'm just solving for x. We know that that equals 2x plus x. Yeah, there we go. See? Now, that means that I've got 90 plus x equals 3x. Okay, subtract the x, and I get x equals 45. Okay, so it looks like x is equal to 45. Okay, and of course that would make this a 45-degree angle. This would be a 90. So, and yeah, so alrighty. Now let's move along. Now, those are two important concepts about triangles, two foundational concepts. Now let's go down here, and I want to look at this thing called the triangular inequality. If you have the sides of a triangle, like for example, if I have one side is 3, one side is 4, and one side is 5, if we add up any two of those sides, that sum has to be greater than the third side. So for example, if I add up 3 and 4, that's 7, that's bigger than 5. If I add up 3 and 5, that's 8, that's bigger than 4. And 4 and 5, that's equal to 9, that's bigger than 3. So it's reasonable to assume or to believe that could be a triangle. Yeah, you could make a triangle with those lengths. We don't have to assume it, we know. Yeah, that could happen. Now the same is true over here. 3 plus 4 is 7, bigger than 2. 3 and 2, it's 5, bigger than 4. And 4 and 2, 6, bigger than 3. Yeah, so those three sides, you could draw a triangle with those three sides. Now let's look at this one. Let's see here. 2 and 4 is 6, that's bigger than 1. 2 and 1 is 3. Ooh! 2 and 1 is 3, and that's not bigger than 4. So you cannot draw a triangle with those sides. See, it's like this. Think about this. Think about if you've got a side this long, and this long. And you want to try to put those together to make a triangle. Well, good luck. It's not going to happen. And you could play around with it and see, but you can see clearly that, yeah, those are not going, there's no way you're going to take these three lengths and get a triangle out of it. Okay, now let's move along. Now I want to classify some triangles real quick and look at some properties. We have a scalene triangle. And in a scalene triangle, no two sides are congruent. Okay. And these next two are what we're really going to focus on today. The isosceles triangle. At least two sides are congruent. Now, if two sides are congruent, then two angles are congruent, because look, whenever you have congruent sides, like this one and this one, you know that their opposite angles are also congruent. So this angle here is congruent to this angle. Since these sides are congruent, their opposite angles are congruent. Okay? That's a key point to remember. Now, there's an equilateral triangle where all of the sides are the same length. That means all of the angles are the same length. And since there's 180 degrees in a triangle, each angle must be 60 degrees, because we're dividing them into three. We're taking 180 and divide it by 3. Now, so those are the three broad categories of triangles. I want to look at this isosceles and talk about it for a second. We've got the two congruent sides. We call those legs. Okay? And then the other side is called the base. Okay? Now, these legs form an angle, and we call that the vertex, right up here. These angles down here that are formed by the leg and the base, we call those base angles. Yeah, but don't get bogged down in the terminology so much. You know, an isosceles triangle has two congruent sides and two congruent angles. Now, let's just study on this for just a second. Let's suppose that we have this isosceles triangle here, and we want to find x. Okay, so what we're going to do is we're going to say, well, it being isosceles, we've got 3x minus 5. That's got to equal x plus 7. And that means that 2x minus 5 equals 7, or 2x equals 12, or x equals 6. Okay? Yeah. So, you've got a side down here, which would be 5. This down here would be 18 minus 5, which would be 13. And 6 plus 7, that would be 13 over there, of course. See, it works out. Okay. Okay, now, that's just a general isosceles triangle. Now, let's look at a special isosceles triangle where two of the angles are 45 degrees. We call these 45, 45, 90. Okay, 45, 45, 90. That's a special isosceles triangle. Okay. Now, I want to just look at a couple of things here. Let's suppose that, let's just see how the base side compares to the legs. Okay. So let's take a gander here. Let's suppose, now notice this is a right triangle. And I'm going to use Pythagorean theorem on this. Okay. So here I go. I'm going to go L squared plus L squared equals B squared. Okay. See, that's just Pythagorean theorem right there. Okay. Now, let's work this a little more. We've got 2L squared equals B squared. And now we've got, let's see how this is related. Let me solve for, I guess I'll solve for L here. L squared equals B squared over 2. Okay. Now let me take the square root. L equals B over the square root of 2. Yeah. So in a 45, 45, 90 triangle, you have the length of the leg is the length of the hypotenuse divided by the square root of 2. Now, that seems a little bit abstract. Let me do this. Let me rationalize the denominator. I'll just multiply the top and the bottom by the square root of 2. It's not always necessary to do this, but for this case, rationalizing the denominator is going to help us. So if you look at this, we've got, notice that the bottom is going to be the square root of 2 times the square root of 2. Okay? So we've got a 2 on the bottom. So we've got the square root of 2b over 2. Now, that means, if you look at this, the length is equal to 1/2 b times the square root of 2. See? So I can just, rearrange that a little bit. Notice up top we got the square root of 2b, b square roots of 2, and then I'll just pull that dividing by 2 out front. So look at the relationship here. The length is equal to 1/2 the square root of 2b. Okay? So let's write that here. 1/2 the square root of 2b. Yeah. Or b square roots of 2, however you want to do it. Okay. So 1/2 b square roots of 2. Yeah, that's the length of the base sides. Now, we could have gone the other way, and we could have said, well, so that's the length. We've got the length as 1/2 b square roots of 2. What if I just multiply both sides by 2? And then divide by the square root of 2. Now we see what b is. B is going to be 2 divided by the square root of 2l. Now, so let's see what that is. B is equal to 2 over the square root of 2l. Now let me rationalize the denominator again. Okay, like that. Okay, top and the bottom by the square root of 2. And now let's see what we got. We got b is equal to 2 square roots of 2l over 2. Those 2's cancel. And now we've got l square roots of 2. Yeah. Now, we could have gotten that just by solving for b up here as well. But anyway, so there's the relationship that we have between the legs and the base. Okay. The leg is equal to 1/2 the square root of 2 times the base, and the base is equal to the square root of 2 times the leg. Okay. Okay. So we keep that in mind. Now I've got these here, they're kind of a little rectangle around them. Okay, so let's see how this goes here. I've got an isosceles triangle here. Okay, there's 3, 3, and this is a 45, 45, 90. And I want to find the missing side here. I want to find the base. Well, the base is equal to the length times the square root of 2. Yeah, that's it. Now, you may not believe that works. So, but notice, all I did was take the length and multiply by the square root of 2. Let's see if it works. Let's take 3 squared plus 3 squared, and we know that equals c squared. Okay. So let's see what, let's just take a look at this. So if we look at this, what we've got here is we've got 9 plus 9, that's 18. And then if I square root that, I get c is equal to the square root of 18. Well, that is 9 times 2, square root of 9 times 2. Square root of 9 is 3. Ooh, look, it worked. So we could have used Pythagorean theorem on that, but anyway. Okay, now this next one, we want to find the length. Well, remember that's going to be, what did we say it was? 1/2 the base times the square root of 2. So this is going to be 1/2 the base times the square root of 2. There it is. And once again, we can check that out. We could do Pythagorean theorem, 1/2 base times the square root of 2. I could square that, and I'd get 49/4 times 2. See, if I square this, square of 7 is 49, square root of 2 is 2. And I could do a couple of those. And that should equal 7, because look what we have. We have 49 over 2 plus 49 over 2. And that's 2 times 49 over 2, which is 49. And remember, this is c squared equals that. So that is 7 squared. So that's 49, which is 7 squared. Yeah, so it works. Okay. I realized I went through that kind of fast, but I was just double checking. You can slow down the video also. Now, also remember this, that if you look at the sine of 45 degrees, and if you look at the cosine of 45 and the tangent of 45, if you look at those things, sine, cosine, and tangent, look what you get. First of all, you're going to take the opposite. Okay, so let's suppose you want, I'm just going to take the sine of this angle. I'm going to take the opposite, which is 1/2 b square roots of 2 over the hypotenuse. Okay, the opposite over the hypotenuse. But I tell you what, instead of me being abstract here and having the L's in there, let's look at one of these triangles. Look, here's the opposite. So we got 3. I'm looking at this one right here. Okay, I've got the opposite over the hypotenuse. And notice those cancel, and I just got 1 over the square root of 2. And if I rationalize the denominator, that'd be square root of 2 over 2. Okay. Now I could do the same thing with cosine, and I get square root of 2 over 2. And then tangent is opposite over adjacent. So that's going to be 3 over 3, which is 1. So sine is square root of 2 over 2, cosine is square root of 2 over 2, and tangent is 1. So those are things to remember also about these are called special angles. But these are values that it's good to lock into your mind. That the sine of 45 is square root of 2 over 2, the cosine is square root of 2 over 2, and tangent is 1. Okay. Now, one way that might make that a little more clear to you is if you draw a triangle and you just have the hypotenuse here, and then you have your x values, and you say, well, notice that x squared plus x squared equals, and let's, for simplicity, let's do this. Let's just make it, this is 1 and this is 1, and this is the hypotenuse down here. Now we know the hypotenuse, we've got 1 squared plus 1 squared equals c squared, and that's 2 equals c squared. So c is equal to the square root of 2. And you could say, okay, sine is 1 over the square root of 2. Cosine is 1 over the square root of 2. So that helps you, that might help you to see where I get these from. Okay, now let's move along. I want to look at equilateral triangles. Now, in equilateral, remember, every side is the same length. And that length is, and every angle is the same. So that angle is 60 degrees. So let me do this. I want to look and see, well, what are the relationships, what are some of the relationships that we can find in an equilateral triangle? And what I want to do, I want to just make an altitude here. See, right there. And I want to cut this bad boy in half and look at it over here. And now, look what we've got. We've got a triangle with 30 degrees because I cut this angle in half, 60 degrees, and 90 degrees right here. So this is called a 30, 60, 90 triangle. That's what that is. Now, notice that this side, this is the length of the side, and I cut it in half, so that's 1/2 S. Now, I want to look at something here. I want to use Pythagorean theorem on this and go this way. I'm going to say, okay, whoops. What happened there? Okay, here I go. I hit the little thing on the side here. So here's what I've got. I've got 1/2 S squared plus h squared equals s squared. See? Just Pythagorean theorem. This side squared plus this side squared equals this side squared. Now, let's see what happens here. I get s squared over 4 plus h squared, I'm calling that h the height, okay, equals s squared. Now, let me go a little further. I want to solve for h. So this is going to be s squared minus s squared over 4. Now, our common denominator there, of course, is 4. So let me just add these fractions and see what I get. I get h squared is equal to 4s squared minus s squared over 4. See, because what I did was I just multiplied the top and the bottom of that by 4. And dig this, we get 3s squared over 4. In other words, yeah, so I just said 4s squared minus 1s squared. Now look what we got. We got h is equal to the square root of 3 over 2s. The square root of 3 over 2s. Made my s different. See, I have trouble with s's. So look at that relationship. The side opposite the 60 degree angle is 1/2 the side length times the square root of 3. Look at that. See? So it's 1/2 the side length times the square root of 3 if I rearrange it. Now this is very important. This is the type question you might see pop up on an ACT or something. Notice we have two angles here. We have 60 and we have 30. The side opposite the 30 degrees is 1/2 the side length. The side opposite the 60 degrees is 1/2 the side length, but it's a little longer, times the square root of 3. So 1/2 the side length times the square root of 3. Yeah, so that's an important concept to keep in mind. Now, so let's look at this. Let's just see how this would work. We want to find the missing sides here. The side opposite the 30 degrees is 1/2 the hypotenuse. The side opposite the 60 degrees is 1/2 the hypotenuse times the square root of 3. And it's always the square root of 3. Okay? So it looks like this is 2 square roots of 3. Yeah. Actually, 3. What am I doing? 3 square roots of 3, right? Yeah, that's it. Okay, now let's look at this one. Now look at this. The side opposite of the 60 degrees is, and we're trying to find S, remember. The side opposite of the 60 degrees is 1/2 S. Let me give myself some more room. 1/2 S times the square root of 3. That's what that 8 is. That's 8, turns out, for this problem. Okay, so let's see here. I'm multiplying both sides by 2, so I got s square roots of 3 equals 16. That means that s is equal to 16 over the square root of 3. Yeah. Now, the other side is just 1/2 of that, so that's going to be 8 over the square root of 3. See, 1/2 of 16 over the square root of 3 is 8 over the square root of 3. See? 2 will go into 16 8 times. Yeah, that's it. Okay. Okay, now here's one more. Side opposite, the side opposite of the 30 degrees is 1/2 the hypotenuse. I wrote 12 in there, but it's 3. I doubled it. Okay. 1/2 the hypotenuse. Okay. And then you can see, okay, this is 1/2 the hypotenuse times the square root of 3. Yeah, there it goes. Okay. So, going both ways there. Okay, now, staying with this equilateral triangle, let's think about the area of this equilateral triangle. And let's suppose we have a triangle with, we've got each angle is 60 degrees. And we want to, now remember the area of a triangle is 1/2 base times height. Okay, so we've got to remember that. And what we have here is we have a triangle and we've got to figure out what the height is. So let's do that. Let's, explore this thing. Okay, so here is 4. This is 2 now, right? And this over here this is the 60 degrees, and this is 30 degrees. So this is 2 square roots of, actually, let me do this. Let me be general here, okay? Let me just be general, okay? So I'm gonna come up here and just make a little triangle, and I've got this is the right angle, and let's suppose I've got the side here, and this is 1/2 the side, right? Okay, now we already know, so this is what we already know. I'm just going back, I'm restating a lot of stuff. The side opposite of the 60 degrees is 1/2 the side times the square root of 3. We already established that. So now let's get the area. The area is 1/2 base, that's 1/2 s, okay, times the height. Okay, so 1/2 base, that's the 1/2 base right there, times the height. So I'm thinking this triangle, it extends on out, and this whole thing here is s. Okay, so let's see what this is. This is s squared, square root of 3 over 4. So it looks like it's the square root of 3 over 4 times s squared. That's the formula for the area of a circle. Not a circle, what am I thinking? The area of an equilateral triangle. If you know the side, square it and multiply by the square root of 3 over 4. Okay, now, so let's see how this works. Here I've got a side is 16, or 4. So it's going to be like this. The square root of 3 over 4 times 4 squared. Yeah, look at that. Square root of 3 over 4 times 4 squared. So that's going to be 4 square roots of 3. Yeah, that's the area, of course, in square units. Now, something else I want to point out here. Let's suppose that we have a 30, 60, 90 triangle. Okay. And I want to get now remember, this side, we've already established that this is 1/2. You know, we're saying the side length is 1, and this is the square root of 3 over 2. Notice that the sine opposite, the sine of 30, opposite over hypotenuse is just 1/2. The cosine adjacent over hypotenuse. And then tangent is opposite over adjacent. Like that. So we've got 1/2 divided by the square root of 3 over 2. Now remember, the way we can do that is invert and multiply. And that would just be 1 over the square root of 3. And I'll just leave it like that. No need to rationalize that denominator. Okay, then we've got the sine of 60, which is going to be the opposite over hypotenuse. Cosine is going to be 1/2. And tangent is going to be the square root of 3. Yeah, if we went through all of that. So look, the fact that I chose the side to be 1, it doesn't matter. It's always the sine of 30 degrees is going to be 1/2. The cosine of 30 degrees, square root of 3 over 2. I just made it 1 for simplicity's sake. Because if I'd made it S, you would have had an S here and an S here, and they would have just divided out. So I just, for simplicity's sake, I made it 1. So here's some things to remember. The sine of 30 degrees, 1/2. The sine of 45 degrees, square root of 2 over 2. The sine of 60, square root of 3 over 2. Cosine of 30 degrees, square root of 3 over 2. Square root of 2 over 2 for 45. And 60, 1/2. And then tangent goes like this. Tangent for 30 is going to be 1 over the square root of 3. For 45, it's 1. And for 60, it's the square root of 3. Yeah. So these are some important things to keep in mind. Keep in your knowledge pot. Okay. All righty. There you go.